Hello friends, welcome back. So in this session we'll be learning about Darrow-Yannet plot. To understand Darrow-Yannet plot, we need to understand about osmosis, or we need the information about osmosis and body fluid compartments, which we have covered in previous sessions. Remember, the knowledge of osmosis, that is the movement of water from one place to another, that is osmosis, and the information of body fluid compartment, distribution of body fluids, is very important to understand Darrow-Yannet plot. So to understand this video, I would request that you first visit those two videos, understand them, and then it will be better if you can go to Darrow-Yannet plot. Although if you have that understanding, you can directly go for Darrow-Yannet plot. So what do we have to understand in Darrow-Yannet plot? Remember, it's a plot, it's a graph, it's a graphical representation about the shifting of body fluid compartments, that is the fluid shifting from ECF to ICF or from ICF to ECF, depending upon various conditions which are going to change the osmosis, or you can say osmotic gradients, osmolarity of the body fluids. So let us first understand the Darrow-Yannet plot, and then we'll discuss the various situations here. As I have told you that various situations like the loss of fluids or gain of fluids, loss of isotonic, gain of isotonic, loss of hypotonic, gain of hypotonic, loss of hypertonic, gain of hypertonic. These are the various changes which occurs either in pathological conditions or in the normal conditions. So what are the components, what are the parts of a Darrow-Yannet plot? Look at the diagram here. On one side of the diagram, there is a larger compartment or a box, and one side there is a smaller compartment or a box. This box, the size of the box, represents the volume. So on the x-axis, this is the ICF compartment, that is intracellular fluid. On right side, that is on this side, we have ECF compartment. So x-axis represents ICF and ECF volume. ICF volume normally is 28 liters and ECF volume is 14 liters. First part. Second part, the height. The y-axis represents the height, and this represents the osmolarity of the body fluids. Osmolarity. Under normal conditions, under equilibrium, the osmolarity of ECF and ICF always equilibrate. Always it means whatever is the osmolarity of the ECF, same goes with the ICF. Whatever is with the ICF, same goes with the ECF, because water moves freely in both the compartment. So whatever may be the changes, end of the day, the osmolarity always equilibrates. So as a normal condition, this osmolarity we will take as a number of 300 milliosmoles. That's what we have discussed for the osmosis. So 300 milliosmol is a normal osmolarity of the plasma, 290 to 300. Now let us see further. The 14 liter is the ECF volume and 28 liter is the ICF volume. So if we are going to discuss about change in a volume, let us try to understand where these points are going to shift. So remember, if ECF volume is going to increase, it's going to move towards right of the 14 liters. So in this direction, it is always increase in the ECF compartment. If the arrow moves in this direction, means if there is the point shift towards this line, indicates decrease in the ECF compartment. On the other hand, for 20 liters, if the volume of the ICF is decreasing, then it shifts to the right side. So this is the decrease for ICF, whereas this direction will be increase for the ICF. So remember this point, because we are going to use this information for calculating or for identifying the Darrow-Yannet changes. So for ECF, right shift is increase, left shift is decrease. For ICF, right shift is decrease, left shift is increase. For osmolarity, if the overall height of the graph increases, it is increase in osmolarity. If the overall height decreases, it will be decrease in the osmolarity. So if it goes in this direction, it will be increase osmolarity. If it goes in this direction, it will be decrease in osmolarity. And depending upon these changes, we can have, with this movement, this shift, we can have 6 types of changes here. But to go further, to understand those 6 types of changes, like gain and loss, gain of isotonic, loss of isotonic, gain of hypotonic, loss of hypotonic, gain of hypertonic, loss of hypertonic. So to have these 6 changes, remember, we have to obey certain rules here. What are those rules? I want you to learn them very carefully. Those rules of the Darrow-Yannet plot. Number 1, always start with ECF volume. Always start with ECF means always you read the graph with the change in the ECF volume. As I have told you, being a clinician, you always have ECF as one of the area where you can work. ICF is never in directly contact with the clinician. You always work on ECF and then the changes in the ICF. So whenever you read the plot, always start with the ECF volume, whether it is increasing or whether it is decreasing. So always start with ECF volume. Then check the ECF osmolarity. Check the osmolarity. Although osmolarity is going to equilibrate, but to initiate, we'll go for ECF osmolarity, because you're going to plot them, we're going to read them. So ECF volume and ECF osmolarity, and finally the ICF volume and ICF osmolarity. So you never read from ICF to ECF. You never read the Darrow-Yannet plot from left to right. You always read the Darrow-Yannet plot from right to left. That is from ECF to ICF. Always read from ECF to ICF. Never read them from ICF to ECF. Never. Okay. So always start with ECF volume and then move on to the ECF osmolarity. Alright. Let us take, for example, the number first. So we'll be drawing 6 different plots here. 6. Okay. And we will be quoting one of the clinical condition for each of the 6 changes. So let us begin. And how do you learn them? Remember, always you learn the graphs by drawing them rather than by reading them or looking at them. So once you get to know with the session, just try to draw those graphs, those plots on your own once again. That will improve the thinking power towards the plot, and recall value will increase. Recalling of these plots during your exam time or during your clinical experiments, or you can say during your clinical work, will be helpful. Let us first go with the isotonic changes. We are going to discuss about isotonic fluid gain and isotonic fluid loss. Isotonic. So we can have 2 conditions. We can have either gain or we can have either loss. So remember, here I'll be drawing the plot, a normal one, and I will be plotting them on the same graph, the changed one. So the black color will be the normal and the changed will be the red one. The black color will be the normal plot and the red line on that plot will be the changed one. So let us go with the first one. Isotonic gain. What happens if a person gains isotonic fluids? If a person gains isotonic fluid, that is volume expansion in a body with isotonic fluid. Example, you are giving IV saline. So you just write an example here, a clinical case of intravenous saline. IV saline. Alright. So what happens when you give an isotonic fluid to a person? See, let us first draw the normal plot. So we have the ICF compartment and we have the ECF compartment. Always remember, the ICF is double the ECF. 20 liters is double the 14 liters. So always keep the ICF compartment as a bigger one. And that's one of the indication, that's one of the hint you can always use during exam, that which is ICF and which is ECF. So this is a normal plot. Now we are talking about gain. We are talking about the gain of isotonic fluid. So when we are talking about gain of isotonic fluid, remember, a gain always indicates gain. The word gain in the isotonic fluid will always indicate increase in the volume. So first thing is, we will increase the volume of the ECF. As we have following the rules, first start with ECF volume and then go with ECF osmolarity, and then you move on to the ICF volume and ICF osmolarity. So because it's a gain, isotonic gain, remember, ECF volume will be increasing. ECF volume will be increasing. So we have marked with ECF volume with red color. It has increased. We have moved it towards the right. The volume has increased. Now ECF osmolarity. What happens to the ECF osmolarity? The fluid which we are giving here, the fluid which is gaining, is an isotonic fluid. Isotonic fluid means the fluid which is same as that of water and salts as same as that of body fluids. So there is neither net increase in only water or net increase in only salt. We are not increasing only water or we are not increasing only salt. We are increasing both of them same as that of body fluids composition. So osmolarity will not change. We are not giving pure water or we are not giving only salts. We are giving isotonic saline. Saline salt concentration is same as that of body fluids. So osmolarity hardly changes, and it doesn't change in fact actual. So we will mark with the same height of osmolarity. So this indicates osmolarity is not changing. Let us just join them, and we have this new ECF compartment now. Now ECF volume has increased and osmolarity has not changed. Now what does this indicate? This indicates that because ECF volume has increased and osmolarity has not changed, the exchange of water from ECF to ICF will be same as that from ICF to ECF, because under isotonic condition the net movement of the water is zero, means the equal movement of water occurs. So ICF will not see, or there won't be any changes in the cellular volume. So RBC volume won't change. We give isotonic saline so that RBC volume does not changes. This means there is no net movement. There is no net movement from either ECF to ICF or ICF to ECF. Both of them equal. The water movement in both the compartments equally. So ICF volume does not changes. I'll just mark here. ICF volume does not changes, and ICF osmolarity also does not changes. This is very interesting here. A fluid which will only change the ECF volume is going to be very useful in conditions where you want to increase the volume of the blood in management of blood pressure. If there is excess loss of fluid, isotonic fluid, there is blood loss, hemorrhage, and you want to increase the blood pressure, so the best way is to increase the volume of the blood isotonically, so that the blood volume will increase, blood pressure will increase, and you will not lose that blood going, that fluid going into the cells. So the fluid remains in the ECF. So you can say increase in volume of ECF. So ECF volume increases. We'll add on those highlighting points here. ECF volume increases. ICF volume no change. ECF osmolarity. ECF osmolarity no change, and ICF osmolarity no change, although they will equilibrate. So the answer will at the end of the day will be same for both of them. So only ECF volume is increasing, ECF osmolarity is not changing, ICF osmolarity is not changing, and ICF volume is also not changing. This will be helping in understanding one more thing, that is the blood pressure in this condition will increase, whereas cell volume in this condition will be, that is volume of RBC will remain same. The mean cell volume remains same. There is no change in the mean cell volume, MCV, that is the mean cell volume, or you can say the volume of the RBCs. Okay, so remember these features. You might have a clinical case where they will give certain things, like a person has been managed for a particular condition, and his ECF volume is increased without changing in the ICF volume, without changing in the ICF osmolarity, what type of management is done here? So if only ECF volume is increasing without any further change in any volume or osmolarity, it is gain of isotonic fluid. The person is given isotonic saline. Remember, this is what you are supposed to understand. And if you look only at the graph, then we should be able to identify that what are the changes which are happening. Going to the next one, let us go to the next one. The isotonic loss. What happens if there is loss of isotonic fluids? The isotonic loss of isotonic fluids. Say for example, hemorrhage or diarrhea, where there is loss of isotonic fluid. Diarrhea is very common where there is loss of excess of ECF volume, and it is isotonic loss. So loss of isotonic. Now we'll draw the normal one first, and I wish if you could draw here with me. Keep taking your book, and just I'll take a pause so that you also try to think and draw the simultaneously the changes along with me. So we have ECF compartment, we have ICF compartment, and we have osmolarity. Same 14 liters, 20 liters, and 300 milliosmoles. Now, going with the change one. Now we are talking about isotonic loss. Isotonic loss. So when there is loss, and our rule is that you always start with ECF volume or osmolarity. You always start with ECF volume. So when there is a loss, you remember, when there is a loss of fluid, the ECF volume decreases. The ECF volume decreases. So there is decrease in ECF volume, and we'll just mark this decrease in volume. Now it's a loss of isotonic fluid. We are not losing only water. We are not losing only salts. We are losing salt and water in equal proportion. So the osmolarity again won't change. The osmolarity remains same. Again, we will join these 2 points here. And now this is the new ECF compartment. This is the new ECF compartment. And because ECF osmolarity remains same, there is no net movement of water either from ECF to ICF or ICF to ECF. It remains same. The water movement remains same because the osmolarity remains same. And because there is no net change, the ICF volume does not changes. So ICF volume remains again same. And that what happens here? Only ECF volume is decreasing. Remember, only ECF volume is decreasing, but ICF volume is not changing. ECF osmolarity is not changing. ICF osmolarity is also not changing. Only the change things are, there is ECF volume decrease. I will write down only the changes here now. The ECF volume is decreased. Fine. Then the blood pressure is decreased. Mean cell volume, no change. Mean cell volume, no change. The RBC volume remains same. Very common example is either you can say an acute hemorrhage, or you can write down here as diarrhea. So one of these examples is good enough to identify these loss of isotonic fluid. So now we have got 2 graphs in our place. One is the gain of isotonic fluid and the loss of isotonic fluid. So 2 graphs are done. We are left with 4 more graphs. Let us go with the hypotonic fluid changes. So we are going to have a loss of hypotonic fluid or a gain of hypotonic fluid. These loss and gain words are quite easier to use, which I am using in this session. Various books use other terminologies. Some people use as hypotonic contraction. Now people do get confused because of these words, but remember, at the end of the day, it's the information or the knowledge which remains same, that is a loss of isotonic or a gain of isotonic. Now hypotonic contraction means in our body there is decrease in the body fluid and the environment is becoming hypotonic. So that term is quite different as what we are using here right now. So don't get confused. Don't get confused with those terms. And here I am using a simple terminology here, which is a loss and gain of the fluid from the body. So we are losing the fluid or we are gaining the fluids. In that term I am explaining. Okay, the word contraction becomes quite very different here. Okay, but the knowledge remains same. The overall fundamentals remains same here. There is no change in the fundamentals. Only the terminologies which are used are quite different here. If you find any difficulty, please do let me know. I'll again sort out those doubts. Yes. Okay. So now we'll go with the hypotonic. We are done with isotonic gain and loss. Now we'll be going with hypotonic gain and loss. So let us go with the hypotonic fluid. Now what is hypotonic? First of all, hypotonic means a fluid which has less salt and more water. The word hypotonic means less salt and more water. Now less salt in comparison to what? Less salt in comparison to the body's osmolarity. Our body's fluid is isotonic. So if I am losing an hypotonic fluid, means I'm losing more of water, not the salt. I'm losing more of the water. Remember, hypotonic word means more of water, less of salt. To make it easier, for here we will say hypotonic means water, only water. So if a person is losing only water, hypotonic loss is only losing water, and hypotonic gain means only gaining water. No salts are gained. Neither salt are lost, neither salt are gained. Only water is lost or only water is gained is hypotonic loss or hypotonic gain. So first we'll go with hypotonic gain. As our custom, we are going to write down the gain first and then the loss one. So gain, hypotonic gain. Let us take one example. Suppose if you are thirsty and you drink 4 to 5 glasses of tap water, that can be example of hypotonic gain. Only plain water is been taken. Or you can say a person is having a marathon runner, losing large amount of sweating, and he drinks only plain water, that too in very large quantity. So it's only hypotonic gain, means person is gaining only water. I will write down here, only water is gained, only water. This is just you can say a hypothetical statement that only water, but ideally we gain a light amount of salt but more amount of water is gained. So water is changing, the amount of water. Now let us draw the graph first and then I will give the clinical conditions here, and I would request you also try to guess which clinical condition it is. So an hypotonic gain, we'll draw the first normal plot, and this is our ICF compartment and this becomes our ECF compartment. Now the term is hypotonic gain. So gain, the word is gain, and as we know, when we use the word gain, first we are going to change the ECF volume. So ECF volume in gain means we are gaining more water. The person is gaining more water. So ECF volume is going to increase. So there is increase in the ECF volume. There is increase in the ECF volume. That is hypotonic gain. Now person is gaining only water. More of water is gained. Salt is not gained here. So the ECF osmolarity, the salt concentration, will be decreasing because we are taking more water and not the salt. So the body's salt are going to get diluted. It means like you are taking a spoon of salt and you add it more and keep on adding water on it. So what happens? The salt concentration will keep on decreasing. It will become more and more dilute. So more dilute, the salt concentration is decreasing, means osmolarity will decrease because more water is increasing, not the salt. So body's salt concentration, body's osmolarity will be decreasing. So ECF osmolarity decreases and ECF volume is increasing. So the first change is done. ECF volume ACF osmolarity. Now this new environment of the ECF is going to show change in the ICF, because ECF is hypotonic. You can see ICF is quite at higher point right now and ECF is at lower point in osmolarity. So because ECF is now hypotonic as compared to the cells, I'll repeat, ECF is hypotonic as compared to the cells. It means ICF is hypertonic and ECF is hypotonic. ICF is hyper, ECF is hypo. And we have discussed in osmosis that the fluid, the water, always moves from hypotonic to hypertonic. Remember this thing, the water always moves from hypotonic to hypertonic. So there will be a net movement of water from ECF to ICF. I repeat, the net movement means there is more of water movement from ECF to ICF, not ICF to ECF. So water will move from ECF to ICF, and if water is moving from ECF to ICF and not coming back, the ICF volume will increase. And what we are increasing? We are only increasing the water here. So ICF volume will increase, but ICF osmolarity is not increasing. So volume increases and osmolarity ultimately equilibrates. And this is the new change what you will see in the Darrow-Yannet plot on the gain of isotonic, loss of or gain of hypotonic fluids. So gain of hypotonic will show these changes here. Now you know this is a very interesting plot here. This condition is seen in the surgical areas, in surgical setup. It's called as SIADH, called as syndrome of inappropriate ADH secretion. That is anti-diuretic hormone. SIADH, syndrome of inappropriate ADH secretion, where there is excessive ADH is secreted because of post-surgical stress. What happens in surgery? During surgery, there is incisions which are made, and there is a loss of blood and fluids. So as a loss of fluids and blood from the body, the hypothalamus secretes excess of ADH, so as to just to go for preserving as much volume as it can. And in that case, there is excessive amount of ADH being secreted from the hypothalamus. That's why syndrome of inappropriate ADH secretion. Now what happens here is that this ADH hormone, that is anti-diuretic hormone, it causes excessive reabsorption of water from the kidneys. So from the nephrons of the kidneys, the water is reabsorbed. Salts are not being reabsorbed. Salts are remaining as it is, but the water is continuously reabsorbed more than required water, and the body's water environment is increased. That is hypotonic gain, and this causes this type of situation here, where ECF volume is increased, ICF volume is increased, ECF osmolarity decreases, and ICF osmolarity follows the same, that is decreases. So ECF volume increases, ICF volume increases, ECF osmolarity decreases, and ICF osmolarity also decreases. What happens to the blood pressure? Here you will see the blood pressure will be increased. The MCV, that is mean cell volume or mean corpuscle volume, also increases. So these situations which are the changes which are observed in a patient's body. SIADH, syndrome of inappropriate ADH secretion, can be one of the explanation for this type of plot. So remember, overall height has decreased, but it become broadened. Now what happens if you go for hypotonic loss? Again, the interesting one. We have discussed isotonic gain, isotonic loss, hypotonic gain, and now we'll go for hypotonic loss. So take out your pen and pencil and again try to draw along with me what happens when there is a hypotonic loss here. So for hypotonic loss, means there is a loss of more water and salts are remaining in the body. We are losing more water We are losing more water. Salts are not lost. So again, I will discuss the clinical case at the end of the plot. Let us draw again the same situation here. We have ICF compartment and we have ECF compartment. So what happens now? Let us see. Now we are talking about loss of hypotonic, means loss of more water is lost. More water is lost. So person is losing more of water here. Person is losing more of water. Let us go with the changes now. So if there is loss of water, a person is losing more water and salts are remaining in a body. What are the changes? Hypotonic loss. First, let us go with the principle. When there is a loss word, means the volume is decreased. The volume is decreased. So decrease in a volume is the first change. Then as the volume is decreased, the ECF volume decreases. What happens to the ECF osmolarity? Now try to think here. We are losing water and salt remain in a body. We are losing more water. Salt is remaining in a body. So in a body, in our ECF, the salt concentration has increased. The osmolarity has increased. So ECF osmolarity increases. ECF osmolarity increases. So there will be decrease in ECF volume because it's a hypotonic loss, but there will be increase in ECF osmolarity because only water is lost but salt remains in the body, and hence we have such type of changes in the ECF compartment. So what has happened? ECF salt concentration has increased but ECF volume has decreased. Now look at the change on the ICF side. Now ECF is hypertonic and ICF is hypotonic as of now. ECF is hypertonic and ICF is hypotonic. And we always go with one principle, that is the fluid always shift from hypo to hyper. From hypo to hyper. So water moves from ICF to ECF. Water moves from ICF to ECF. The water is moving from ICF to ECF. And because water is moving from ICF to ECF, the ICF volume will decrease. The ICF volume will decrease. And again they will go for equilibration because only water is moving from cells to the ECF. Only water is moving. So cells are losing water but salt remain inside the cell, and therefore ICF osmolarity also increases. So we'll have equilibration at the end of the day, and hence we have such type of plot. Here you can see here that ECF and ICF volume, both of them have decreased, and ECF and ICF osmolarity, both of them have increased. Where do you find such changes? It will be the opposite of what we have seen in the above graph, that is SIDH. Here you will see a condition where there is no ADH secretion. There is a loss of ADH secretion or loss of ADH activity called as diabetes insipidus. DI or diabetes insipidus. In diabetes insipidus, what happens? The ADH hormone is either not synthesized or less in quantity, or either ADH hormone is failing to work on the cells of the nephron. So what happens? The kidneys are unable to reabsorb water and excessive water is lost from the urine. So person is losing more of water from the urine as opposite into the furious situation. So when you are losing more of water, the salt remains and you see the changes. So diabetes insipidus is one of the best example to have this type of plot. So you can always say that hypotonic gain will be seen in SIDH and hypotonic loss will be seen in diabetes insipidus. So again, what happens to the blood pressure? What happens to the blood pressure here? Can anybody? Yes, the blood pressure will be yes, decreased. Great. So there is decrease in blood pressure. And what about the osmolarity? Yes, osmolarity has increased. So what happened to the cell volume? The MCV. The MCV is also decreased, as opposed to the previous one where BP increases, MCV increases. Here BP decreases, MCV decreases. That is mean corpuscular volume or mean cell volume. So volume of the RBC is also decreased and blood pressure also decreases. So this is the very interesting change in the hypotonic environment. So we have covered as of now 4 graphs: isotonic gain, isotonic loss. Let us just, before going to further 2 graphs, I'll just browse what we have done so far. You can see we have done almost 4 graphs here. The first one was isotonic gain. Second one was isotonic loss. Then we have done with hypotonic gain, and then we are doing with hypotonic loss. Now the fifth and the sixth, that is last 2 changes about hypertonic. So what happens if there is hypertonic gain or hypertonic loss? Now what does hypertonic indicates here? The word hypertonic indicates salty environment, more of salt, more of salt. Now, so now we'll use the word salt, not the water here. As in case of hypo, we have usually water, we will use the word salt here. So if a person is losing salt or person is gaining salt, what happens here? So hypertonic means the salt is lost or the salt is gained in more quantity as compared to water here. So hypertonic gain means a person is gaining more salt. More salt is gained. Let us take an example here. Seawater. Seawater, oceanic water is almost 4 to 5 times, 4 to 5 to 6 times concentrated as that of plasma. It is almost 2000 milliosmoles salt concentration as compared to plasma. So very salty. Sea water is very salty. So if a person is drinking sea water, he is gaining more salt. Try to understand this point. And the water is not gained in the quantity in which the salt is gained. So what happens now? Let us draw the normal plot first. Again, so again we have the ICF compartment, and then we have the ECF compartment. So gain, first of all we will see the gain. Person is gaining, so its gain means the ECF volume is increased. ECF volume is increased. Now what he is gaining? He is gaining more of the salt here. He is gaining more of the salt. So if the salt is gained in higher quantity, what happens to the osmolarity? So ECF osmolarity will increase because salt concentration has increased. So now this is the changes which we'll see in the ECF compartment. These are changes which we'll see in the ECF compartment. Gain of more salt in the ECF. Now ECF is hypertonic as compared to ICF. ECF is hypertonic as compared to ICF. So now if ECF is hypertonic, ICF is hypotonic, the water always moves from hypotonic to hypertonic. So water will move from ICF to ECF. Water will move from ICF to ECF. So what we'll see here is that the ICF volume will decrease because water is moving from ICF to ECF. So ICF volume will decrease. And now what will happen to the osmolarity? Of course, it will equilibrate. So ICF osmolarity equilibrates with the decreased volume. And that's what you see with the hypertonic gain. Quite different, isn't it? Yes. So keeping these changes in mind, we'll write down what are the changes here. So changes here which are visible are hypertonic gain. Remember, it's a hypertonic gain. So ECF volume increased, ICF volume decreased, ECF osmolarity and ICF osmolarity. ECF and ICF osmolarity overall increased. What are the other changes? What are the other changes here? Blood pressure. What happens to the blood pressure? Can anybody tell me? Yeah, blood pressure increased. What happens to mean cell volume, mean corpuscular volume? See here, it's ICF volume decreased. So increase in blood pressure but decrease in the mean cell volume. Remember, ECF volume increases, ICF volume decreases, and ECF and ICF osmolarity has increased, and blood pressure has increased, and mean cell volume has decreased. So example, sea water consumption. I am writing one of the example is sea water, consuming sea water. A person, those who are stranded in sea, those who are lost into the sea or ocean, they often suffer from this type of condition. They as a part of thirst, they drink excess of sea water which is available, and this further you can say damages the situation in the body physiology, and they ultimately die because of excessive salt consumption, which leads to more loss of water in act of removing them. That we will discuss. It is called as the water diarrhea, because he is taking more salt and body wants to remove that extra salt, and body removes the extra salt by extra water. So he drinks 1 liter but he removes 2 liters. So it's called as one of the serious diarrhea situation. Okay, now hormone. Which hormonal condition will cause this? The hormone aldosterone. If there is increase in aldosterone hormone, hyperaldosteronism, then aldosterone causes excessive reabsorption of sodium ions. So there is more of sodium which is reabsorbed, and that causes the changes of hypertonic gain type of situation. Okay, so hyperaldosteronism is one of the example for this type of changes. Let us go with the last one of the plot, that is hypertonic loss. Hypertonic loss. Now what happens if there is loss of hypertonic fluid? Means a person is losing more of the salt and water is remaining in a body. Person is losing, more salt is lost. More salt is lost and water remains. More salt is lost and water remains here. So let us see what are the changes here. Again I will draw the plot here. So this is the plot here. All right, now let us see with the loss part first. Because there is a loss of fluid, the ECF volume will decrease. The ECF volume is decrease. Now what he is losing? He is losing an hypertonic fluid. Means more amount of salt is lost. Salt is lost more, water remains. So if more salt is lost and water remains, means body's water environment becomes more, means body's osmolarity is decreased. So there will be decrease in the osmolarity now. So now ECF volume decreases, ECF osmolarity also decreases. Let us join these 2 points here. So this is the new ECF changes. These are the new ECF changes. Now ECF osmolarity is decreased here, and ICF is quite at higher point as of now. So ICF is hyper, ECF is hypo. ICF is at hypertonic, ECF is hypotonic as of now. So what happens? The fluid or the water moves from hypotonic to hypertonic. So it shifts from ECF to ICF. It goes from ECF to ICF. Now if water is moving from ECF to ICF, what happens to ICF volume? Water is moving from ECF to ICF. So ICF volume will increase. ICF volume will increase, and because only water is moving into the cells, the cell osmolarity also decreases. Because only water is moving from ECF to the cells, the cell volume will increase, but the salt concentration will decrease. So osmolarity of the cell will decrease and hence it will be same as that of this ECF hypotonic. So this becomes your new change plot. Now here look at the changes here. So example, what will be the example here? Example, decrease in aldosterone. The hormone aldosterone decreases, and which causes a decrease in sodium reabsorption. There will be more of sodium loss, salt loss, and the water remains. So what are the changes here? The ECF and ICF. So for the ECF and ICF volume, for the volume of ECF, yes, ECF volume will be decreased or increased? ECF volume decreased. ICF volume, what happened to ICF volume here? Yes, please. ECF volume decreases, ICF volume increases. And osmolarity, overall osmolarity decreases. Overall osmolarity decreases. Blood pressure decreases. Blood pressure decreases. MCV increases. Mean cell volume has increased. So these are the changes which you can observe in a person with when there is a loss of hypotonic fluid. So in this way we have covered 6 different plots: isotonic gain, isotonic loss, hypotonic gain, hypotonic loss, hypotonic gain, and hypotonic loss. Remember, try to learn this graph by drawing them rather than by just looking at them. So here we'll stop. We'll go with the next session on resting beam potential. Till then, thank you.